Okay, so just going through, you would just divide everything by 2. You would get pi on 12, 5 pi on 12, 13 pi on 12, 17 pi on 12, negative 11 pi on 12, negative 7 pi on 12. And then just from that, can you guys see that I haven't there might be more solutions. I only get to something which is which is not quite negative pi here, but I need to go all the way around to negative 2 pi. So this one here looks like I'm probably okay. 13 pi on 12, 17 pi on 12. Okay, let's just stop and notice something. All right, pi on 12 to 13 pi on 12, what have you added?
$12
12 pi on 12, or pi. Yeah? 5 pi on 12 to 17 pi on 12, what have you added? Same thing. So we've just added the period of, in this one, the period's pi, yeah? So you don't have to do this 2x thing here. First, what you could do is divide this 2x by 2 both sides, and you get pi on 12 and 5 pi on 12, and then just keep on adding periods of pi until you get it within your domain. Okay? So let's use the CAS to work out all the solutions, and then let's do one more together. Okay? So if you go into your calculator settings, solve sine of, it was 2x equals 0.5 for x when x is between negative 2 pi to 2 pi. How many solutions have I got? 1, 2, 3, 4, 5, 6, 7, 8. Okay. And how many do I get here? 1, 2, 3, 4. So those are the positive ones. And I'm missing 2 there. So I just need to subtract pi from this one, subtract pi from this one, and I would get within my domain. Alright? So let's just finish that one off. What are the 2 missing values? That one goes around 1 full revolution, which is pi, because I've already divided by 2 here. So it should be negative 23 pi on 12. Is that right? And then this one, subtract pi, you would get negative 19 pi on 12 as exact values. Yeah? So how about I get you guys to try and do one, and then I'll start writing out the solution as you go. Okay? So can you do for me I'll try and do that. arithmetic slow. So I'm just going to check with the calculator, and I'll try and make it exact values. Exact. So what do I want to do? Cos of 2x equals minus root 3 divided by 2 for x, and that one between negative pi x and 3 pi. Okay, so it looks like I got it right. Alright, so all those ones are the solutions, and we'll look at it visually in a moment, but we'll go through the process again. So what did we do was we just used our exact values stuff, right? We know that root 3 and 2 is a special value, and we know that 2x has to be 5 pi and 6 or 7 pi and 6, because root 3 on 2 is adjacent on hypotenuse for cos, so it's pi and 6. But I'm after where cos is negative, so it's in this quadrant and this quadrant, so you have to go pi minus pi and 6 to give you 5 pi and 6, and pi plus pi and 6 to give you 7 pi and 6. And then I just divide everything by 2 to get x, that's what I'm trying to solve for. And then I know for cos 2x, the period's pi. So just add multiples of pi to these guys, or subtract multiples of pi if you're going the other direction as well, to fit in within this domain. Okay? So what might make it easier is to look at common denominators. Alright? If you're going to be adding a certain amount each time, so negative pi is negative 12 pi and 12, and 3 pi is 36 pi and 12. So I'm just adding 12 pi and 12 to that one. 5 pi and 12 plus 12 pi and 12 will give me this one. 7 pi and 12 plus 12 pi and 12 will give me this one. And I just kept on going until, if I did it any more, I'm going to go over the domain, yeah? 29 pi and 12, if I add 12 pi and 12 over there, that's going to give me 41 pi and 12, which is bigger than this bit, so it's outside the domain. And then you just go back the other way. You take that angle and you subtract pi. You take that angle, you subtract pi. I may have mixed that up, but that's the method, okay? And then let's look at it visually. So we've got cos of 2x, looks like that, and we'll make it in the right domain between negative pi less than x less than 3 pi. So now it looks like that. And I had the line y is negative root 3 on 2. Okay, so how many solutions have we got? One, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Alright? So that's how we solve for trigonometric functions for sine and cosine. Okay?
Why do we get the 17 pi and 12? So, just not entirely sure about that.
The 17 pi and 12 would be the 5 pi and 12 value plus 12 pi and 12. So plus the period. Because if you just zoom in on the first two solutions that you get, okay, that one there should be 5 pi on 12. Control Enter, hopefully. Can you see that's that one, that's that one. 5 pi and 12 is 1.309. Okay, so that's the 1 point, it's rounded up here. So that's that solution. And then to get to the next one, if you add the period, you get back to there, and the period is pi. So we've added the period to get back to that point. I hope that's what I've shown visually. There starts repeating after, yeah, there. Okay, so let's intersect there. That's 4.45, so that should be my